Welcome friends, Igor is here, and in this video we will discuss linear algebra applications to input-output models in economics. We will construct and solve the Leontief models. The economy is a complex interdependent structure. Let's suppose that the economy involves n interdependent industries. The output of each industry is needed as input by other industries. For example, to produce cars, you need steel. For modeling simplicity, we are going to assume that each industry produces exactly one type of commodity. Let Aij denote the input of industry I that is necessary to produce a unit output for industry J. These numbers are called input coefficients in this model, and we can construct the so-called input-output matrix. This matrix describes the interdependencies of the industries. But the commodities produced by the interdependent industries may also be used by other non-producing sectors of the economy. All such non-producing sectors are grouped into one single so-called open sector. Let Di denote the demand from the open sector for commodity I, and Xi denote the total output of industry I. Then the demand from industry J for commodity I is given by Aij times Xj. Let's understand why. Aij is the amount of the commodity from industry I which is necessary to produce a unit value of commodity J. So if the total production of commodity J is Xj, then the total demand from industry J for commodity I is given by Aij times Xj. To have a balanced economy, the output of each industry must meet the demand. The demand for the output of industry I consists of the demands of each of the individual industries plus the demand from the open sector. Notice that the balancing equation is a linear equation in variables x1 through xn. And therefore, the task of balancing the economy consists of solving a linear system. Let's consider an example of a closed economy model. In this case, there is no open sector demand. We are going to look at three industries: steel, auto, and rail. We are given the input-output matrix, which defines the interdependence of the industries, and in this case, the first row corresponds to steel, second row corresponds to auto, and third row corresponds to the rail industry. We need to figure out what the total output of the three industries should be to balance the economy. We use the input-output matrix to construct linear equations that balance the economy. There is one equation for each type of the industry. The total production of that industry must coincide with the total demand for the commodities from that industry. This is a linear system with three equations and three variables. To solve this linear system, let's transform it to a more usual general form when we have all the variables on the left-hand side and constants on the right-hand side. Because we assume that there is no open sector demand, this is a homogeneous linear system. We construct the augmented matrix of this system, and then we apply the Gauss-Jordan elimination algorithm to obtain the reduced row echelon form of this matrix. You may want to check out this video, which explains how to perform Gauss-Jordan elimination. From the reduced row echelon form of the augmented matrix, we see that x3 is a free variable, and therefore there are infinitely many solutions. You can interpret this solution in the context of the original problem as follows. The ratio of the production levels of steel, auto, and rail industry should be in proportion 4, 3, and 4. Now, let's consider an example of an open economy model. We still have the same three industries: steel, auto, and rail. We have a new input-output matrix, and now we have a demand from the open sector. Let's try to balance this economy. First, we write the equations that balance the economy. The output from each industry is equal to the total demand for the commodities of this industry. We obtain a system of three linear equations in three variables. Let's write this system in the general form, where all the variables are on the left-hand side and all the constants are on the right-hand side. Then we write the augmented matrix of this linear system. Notice, it is a non-homogeneous system now because there is a demand from the open sector, and we obtain the reduced row echelon form of this matrix. Problems that come from real-world applications usually require the use of software to obtain numerical solutions. This is what was done in this example. Now, the reduced row echelon form of the augmented matrix tells us that this system has a unique solution, so we know exactly what the outputs of each of the industries should be to balance the economy. If you found this video useful, please like and subscribe to help others discover this content. I hope to see you later infinitely many times. Have a good day.